In this video, we're going to explore an important topic of math: concepts of matrices. We're diving into three important matrix operations. Number one, addition of matrices. Learn how to combine two matrices quickly and correctly. Number two, subtraction of matrices. See how we find the difference between two matrices. Number three, transpose of a matrix. Understand how flipping rows and columns reveals new patterns. We'll go step by step with clear examples. Let's get started.
So let's discuss the addition and subtraction of matrices. Now, the addition of matrices, if we have matrices A and B, and they both are of the order m by n. So they have the same order, they have the same number of rows and the same number of columns. Then we can add them up, as in A plus B. So the order of A must be equal to the order of B. And that is the only requirement we have to add A and B. So let's just see a small example of this. If we have matrix A here as this, and if matrix B is this, and we want to find A plus B. Now, the order of A is 1 by 2, 1 row, 2 columns. And the order of B is also 1 by 2. So they can be added up. And how do we add up A and B? Well, we'll add up the corresponding entries. The first element of A will be added to the first element of B. So 1 plus 3. And the second element of A will be added to the second element of B. So 2 plus 4, which will give you 4 and 6. That will be the result. Now remember that the order of the resultant matrix will be the same as the order of A and B. So just remember, you have to add up the corresponding entries. Now, see this example here. We have to add A and B. We have to find A plus B. Now, first, we must make sure that they have the same order. A is of the order 2 by 2. B is also of the order 2 by 2. So indeed, they can be added up. Now, we have to find the sum by adding the corresponding entries. So, see here. The corresponding entry of 1 here is 2. The corresponding entry of 5 is 0. And as you can see in the resultant matrix, it's 1 plus 2 and 5 plus 0, 4 plus 5, and 3 plus 6. And this is the resultant matrix. Now, see the subtraction of matrices. It is similar to how we have done the addition of matrices. It also has the same requirement. A and B both must be of the same order, m by n. So, the order of A is equal to the order of B. And in this case, we'll just subtract the corresponding entries instead of adding them. So if we have, say, matrix A as similarly, as we did before, 1, 2, and B is 3, 4. If we have to do B minus A, well, you'll simply just write it like 3, 4 minus 1, 2. And the resultant matrix will be subtracting the corresponding entries. So 3 minus 1 and 4 minus 2. And this will be a result. Now see this example here. We have to subtract A and B, A minus B. So let's first see the order of A is 2 by 2. 2 rows and 2 columns. And the order of B is also 2 by 2. So they can be subtracted from one another. So A minus B, well, as we've seen before, we'll subtract the corresponding entries. So 1 minus 1, 6 minus 2, 5 minus 9, and 5 minus 3. And this will be your resultant matrix. So let's discuss the transpose of matrices. Now, what is the transpose of a matrix? Well, the transpose of a matrix is found by changing rows into columns and columns into rows. So let's see what we'll deal with. So this is how you would denote the transpose of a matrix A. So let's just say we have matrix A here, like this. And we have to find A, we have to find A transpose. So what we'll do here is we'll change the rows of A into columns. So the first row of A will become the first column of A transpose. The second row of A will become the second column of A transpose. And if you look at it the other way of converting columns into rows, that has also happened automatically because the first column of A has become the first row of A transpose, and the second column of A has become the second row of A transpose. Now see this example here. We have matrix A here, and this is how you would find A transpose. The first row of A has become the first column of A transpose. The second row of A has become the second column of A transpose. The third row of A has become the third column of A transpose. And so you have A transpose.
Let's quickly recap what we've learned today. First, in the addition of matrices, we saw that we can only add matrices of the same order by adding their corresponding elements. Next, in subtraction of matrices, the rule is the same: subtract each corresponding element. And remember, the matrices must still have the same dimensions. Finally, for the transpose of a matrix, we learned that it's like flipping the matrix over its diagonal rows become columns, and columns become rows. So, whether you're adding, subtracting, or transposing, always start by checking the size of your matrices. Get that right, and the rest is just simple calculation. Well done. If you found this helpful, don't forget to like the video, subscribe to the channel, and explore our other videos for more easy-to-understand math lessons. See you there.